Okay, so how do we integrate e to the x sine x dx? So this is not a polynomial, so I will not be using the power rule. I cannot use substitution because e to the x will not give me sine x will not give me e to the x. So is it tabular method? E to the x will not go or will not change to 0 if I differentiate it. Even sine x will not give me 0 after differentiating it so many times. So we're left with integration by parts. So we decide for a u. In this case, I'll choose e to the x, and dv is equal to sine x dx. The du is equal to e to the x dx, and the v is equal to negative cosine x. So from the formula uv minus the integral of v du, we have e to the x and then negative cosine x minus the integral of negative cosine x e to the x dx. And this is the same as negative e to the x cosine x plus the integral of cosine x e to the x dx. Unfortunately, we cannot simplify or integrate cosine x e to the x dx directly. So what we can do is to use integration by parts again so that we can get the integral of cosine x e to the x. So we will introduce another set of u. So this time we are just working with cosine x e to the x. I'll choose u to be e to the x, and dv is equal to cosine x dx. So du is equal to e to the x dx, and v is equal to sine x. Again, with the formula, this will become e to the x sine x minus the integral of sine x e to the x and then dx. Again, sine x e to the x cannot be or you cannot get the integral of this directly because there is no direct formula for sine x e to the x. So it seems like we have done integration by parts twice, but we're not yet it's not yet successful. Now if you analyze it, okay, what I want you to see is that we were trying to integrate e to the x sine x dx. That is the given problem. And while we are doing integration by parts the second time, I hope you could see that this is also e to the x sine x. So combining all the solutions, we were able to obtain the first as negative e to the x cosine x plus, and then we solve for the integral of this, and we obtain e to the x sine x minus the integral of sine x e to the x, which is the same as e to the x sine x, and then dx. Now take a look at this and this one. They're basically the same. So this is the case wherein you can actually move expressions and combine them. So to continue, so this will be integral of e to the x sine x dx. If I add this, the opposite of this on both sides, so we have plus integral of e to the x sine x dx. Then the right side is now negative e to the x cosine x plus e to the x sine x. But these two combine simply is 2 integral of e to the x sine x dx, and then equal to the other side e to the negative x, which is negative, then plus e to the x sine x. So to to end the solution, since what we want is just e to the x sine x, then all we have to do is to divide this by 2. So by dividing by 2, we were able to obtain the integral of e to the x sine x dx, which is just negative e to the x cosine x plus e to the x sine x all over 2. And then just add the plus c. So we have plus and then the c. Okay, so that's it. So I hope you were able to understand that when we use integration by parts twice and it's not yet it did not give you the final answer, then you have to check whether the given expression is coming out from the second integration by parts. If that will happen, then you have to move it on the other side and combine them, and then just divide by a certain number depending on the resulting expression on the left. Like this one, this is a 2, so we have to divide by 2, and then after that you can now get the integral of e to the x sine x dx. Okay, that's it.